In this video, we're going to learn a third method for solving systems of equations, and this is by a method called elimination. Basically, this is a form of substitution where we're going to add something that's equivalent to both sides. Now, instead of adding like a 1 to both sides or adding a 5 to both sides, we're going to add the equivalent of, say, like -1 to both sides, but it's going to look a little bit different. Basically, what we're going to choose to do is add the two sides together, okay, where I work down. In this case, I look and say, okay, 2x plus 7 plus 5y, 2x plus 5x is going to give me 7x. Negative y plus y ends up canceling out, and this is why the elimination works, is because one of the variables should cancel out completely. Then this will equal what 8 minus 1 is, 7. So I have the statement 7x is equal to 7. I would divide by 7, and I would get x is going to equal 1. So once again, my solution should be a coordinate point. In this case, my x value is 1. I need to then go back and figure out what my y value is. So I might just choose to use the first equation, doesn't really matter. 2 times 1 minus y is going to equal 8. Okay. 2 minus y is going to equal 8. I subtract 2 from both sides. I get negative y is going to equal 6. So y is equal to -6. Okay, so in this case, my solution would be 1, -6. I can check my answer by plugging it into the second equation. Does 5 times 1 plus a -6 equal -1? In this case, 5 plus -6 does indeed give me the solution that I would like. Let's look at another. In this case, I look at this and say, well, what can I eliminate? If I try to add them, I get 3x plus 3x, which would give you 6x. 2y plus 4y, which would give you 6y. So nothing is able to cancel out. So instead of adding, we're going to subtract the second equation, in which case I need to make sure I subtract everything from here. In this case, the 3x's will cancel out. 4y minus 2y, these are 2y. 15 minus 3 is 6, so y is equal to 3. Once I get the solution, plug it in. 3x plus 4 times 3 is equal to 15. 3x plus 12 is equal to 15. Subtract 12. I get 3x is going to equal 3. Divide by 3, divide by 3. I get x is equal to 1. So my solution once again would be 1, 3. Making sure I list the x first, followed by the y. I can check, does 3 times 1 plus 2 times 3 equal 3? And in this case, I can say that 3 plus 6 does not equal 3. So which means I made a mistake somewhere. So if I track this backwards, I'm going to erase a couple things here. So let's go back to this point. Where I make the mistake is 4y minus 2y is 2y. 15 minus 3 is going to give me 12. Divide by 2, divide by 2. I get a solution of y is equal to 6. So let's try this again. 3 times an x value plus 4 times 6 is going to equal 15. So I get 3x plus 24 is equal to 15. Subtract 24 from both sides. I get 3x is equal to -9. Divide by 3, divide by 3. X will equal -3. So in this case, I get a solution of -3, 6. Let's check my answer once again. Okay, so I'm going to go through and say, okay, does 3 times -3 plus 2 times 6 equal 3? In this case, I get -9 plus 12, get equal 3, so 3 equals 3. So my answer checks, and I've confirmed that I have indeed come up with the solution. Okay, and so that, anyway, this is basically the method for substitution. It's particularly valuable when I have the same variables, okay, with the same coefficients, whether it be positive or negative. This is the method that's most easily used with elimination. Now, if I'm given something like 5x minus 2y is equal to 4, and x plus y is equal to, say, 8. It can also be used by this if I was to multiply everything by 2. Okay, I can then set it up where these are going to cancel, okay, and then I can get 7x is equal to 20 and go through the remainder of the process. Of course, this is not working out that pretty in terms of coming up with fractions at this point, but it's that same method that I can go through, and if something doesn't line up perfectly, then I can multiply to be able to get it. So this is what we'll be practicing. Once again, it's the same method, same types of equations, the systems of equations that we worked with in the previous two sections. It's just another method that sometimes actually makes things a little simpler.